Hi guys, I'm Sriram.r studying in Sri Venkateshwara College of Engineering. Subject is Introduction of Mechanical Engineering. Topic is four-stroke engine. Introduction to four-stroke engines. Four-stroke engines are the most common type of internal combustion engines. Powering the everything from the cars to motorcycles, they operate through a sequence of the four distinct piston strokes: intake, compression, and power and exhaust. Principle of four-stroke operation: intake, power, and compression exist. The piston moves down, drawing in a mixture of air and fuel through the open intake valve. The compressed mixture is ignited, forcing the piston back down and turning crankshaft. And the compression: the piston moves up, compressing a air-fuel mixture, preparing it for the ignition. Exhaust: the piston moves up again, pushing the spent gases out through the open wave exhaust. Petrol engine versus diesel engine. Petrol engine, diesel engine. Key differences: uses spark to plug ignite the air fuel mixture and at the right time, typically has a lower compression ratio around 8.1 to 11.1. Diesel engine release on the heat compression to ignite the diesel fuel as much of a higher compression ratio around 14.1 to 25.1. Key differences: diesel engines are generally more efficient and durable but louder and produce more emissions. Petrol engines are lighter, quieter, and more responsive but less efficient. Difference in fuel injection. Now, petrol engines use a carburetor or a fuel injectors to mix air and fuel before entering the cylinder. Diesel engine inject the diesel fuel directly into the cylinder where it mixes with the compressed air. Implications: direct injection in a diesel allows for a more precise fuel control and a higher efficiency. Emission: diesel engines generally produce more particulate matter and nitrogen oxides than the petrol engine. From compression ratios and ignition. Compression ratio: diesel engines have much more higher compression ratios. Achieve the auto ignition method. Petrol engines use spark plugs and to ignite a combustion, while diesel rely on the compression. Efficiency: higher compression in diesel leads to greater thermal efficiency and fuel economy. Emissions: diesel engines generally produce the more particulate and the NOx emission than the petrol. Combustion process compared: petrol engine, spark engine, and the spark ignition of the pre-mixed air and fuel change. Diesel engine, compression ignition of the directly injected fuel and the differences. Diesel combustion is more controlled and efficient, but also louder than the dirtier. Emissions, efficiency, and emissions: diesel engines are generally produce more particulate matter and the nitrogen oxide. Fuel efficiency: diesel engines are typically 20% to 30% of the more fuel efficient than the petrol engines. Environmental impact: diesel emissions are major contribute to air pollution change and the advantages. New engine technologies improving the emissions and the efficiencies of the both petrol and diesel. Maintenance and servicing requirements: petrol engines, diesel engines require regular tunes up, spark plug changes, and inspection of fuel system components. Generally simpler and less costly maintenance than the diesel. Diesel engines need more frequent oil changes and close monitoring of the fuel injection system. Require specialized tools and thus expertise for the proper maintenance and prepare considerations. Proper maintenance is crucial for maximizing engine life and performance in the both times. Diesel engines tends to have a longer lifespan and well maintained. Application and the uses and the causes. Automobiles: four-stroke engines are the primary power source of the both petrol and diesel power vehicles and power generation. Diesel four-stroke engines are commonly used in the generators. Both are backup primary power. Marine applications: both petrol diesel four-stroke engines are widely used to power boats and the ships. Heavy equipment: diesel four-stroke engines are the perform choice for the powering large construction machinery. Conclusion and the future trends of the continued evolution. Four-stroke engines will continue to evolve, becoming more efficient and environmental friendly. Alternative fuels, biofuels, hydrogens, and the other renewable energy sources may replace traditional fossil fuels. Hybrid and the electrical. The rise of the hybrid and the electrical may gradually reduce needed for the four-stroke engines. Emission regulations, stricter emission standards will drive further advancement in the four-stroke engine and technology. Thank you, guys.